Hi, welcome back to class. In our last lesson, we saw the simple machine. We introduced the mechanical advantage, velocity ratio, and efficiency of a simple machine. In this lesson, we will see the simple pulley system. In case you missed our last lesson on simple machine, please do not hesitate to check the description below where we place a link to the simple machine. That said, let's get into class. The simple pulley system is one of the most widely used machines. It's made up of a wheel with a groove at its edge. There are three types of pulleys. You could have the fixed pulley, a movable pulley, or the compound pulley. Let's talk about the fixed pulley. In the fixed pulley, like the name depicts, it's a fixed pulley. It's just one pulley system, that is, it requires less space and obviously it has low mechanical advantage. Why? Because the required effort to pull up a load is almost equal to the load. The second system is the movable pulleys. The movable pulleys, unlike the fixed pulleys, have higher mechanical advantage. Like the name depicts, it's movable. One unique thing about the movable pulley is that the velocity ratio of the movable pulley is equals to 2. And the third system is the compound pulley. The compound pulley is a combination of both the fixed pulley and the movable pulley. For the compound pulley, the more the numbers of pulleys, the higher its mechanical advantage. That is, the less the required force required to pull a load. So it has comparatively higher mechanical advantage. But unlike other sets of pulley, the compound pulley obviously occupies more. With that said, let's take an example to see how to solve questions relating to the pulley. Our question says, a block and tackle of 6 pulleys. Already we've been told it has 6 pulleys and is a block and tackle system. Obviously, my velocity ratio, VR in this case, will be equals to 6. It's used to raise a load of 300 newtons. The load is equals to 300 newtons through a height of 30 meters. If the work done against friction is 200 newton, if work done against friction is 200 joules, calculate the work done by the effort. For this system, since there is friction, we're considering friction, we're going to look at the total effort required in this system will equals work done by the load plus work done against friction. Now, where work done by the load is equals to the load in newtons times the required times the height covered. That is 300 times a height of 30 meters. Now, plus my friction, work done against friction is 2000 joules. That's plus 2000. That gives me 9000 plus 2000. So that the total effort for this system is 11,000 joules. Our second question demands that we calculate the efficiency of the system. Remember from our last lesson that efficiency is the same thing as MA all over VR times 100, permit my pen, times 100 in percent. And also we could say efficiency is the same thing as work output all over work input. My pen is faulty. Work input times 100. I showed both of these. I demonstrated how they equate each other in the last lesson. Please, in case you missed our lesson on simple machines, please do not hesitate to check the description below. Now, that's same thing as work output that's 300 times, my work output is 300 times 30 all over total work input. That's the effort input into it. That's 11,000 times 100%. Now, if you compute this with a calculator, you should come up to 81.8%. Now, the last part of the question wants us to calculate the applied force. Now, to calculate the applied force for this system, let's remember that we said efficiency of the system is the same thing as MA over VR times 100. Now, and we've gotten efficiency to be 82. That's equals to MA over VR. Our VR is 6 times 100. Now, this implies that our MA is the same thing as 82 times 6 over 100. From our calculator, that means our MA is the same thing as 4.92. Now, from our MA, we know that MA, which is the mechanical advantage of the system, is the same thing as load over effort. So that my MA, which is 4.92, is the same thing as a load. It has a load of 300 newtons over effort. Let's tag that as E. So that my effort E will now be the same thing as 300 all over 4.92, which is equals to, from our calculator, that's the same thing as 61 Newton. 61 Newton. So you see that the pulley system is a very efficient system where I can use 61 Newton to drive a load of 300 Newtons. Thank you for staying with us. To ensure you continue to receive such lessons as this, please do not forget to hit the subscribe button. See you in our next class.